Okay, we're back using Pythagorean Theorem applications with kind of algebra constructs. And so let's take a look at this triangle that I have up here, a right triangle. And I've got an unknown length and side lengths named in terms of that unknown length, and I want to find the unknown length. Well, again, I can use Pythagorean Theorem, a squared plus b squared equals c squared, and just see how it comes out. So let's see. Here's my a squared plus, here's my b squared equals, there's the c quantity squared. Now to actually solve for x for this example, it's a little ugly. I might have to sort of undo a lot of things. So x plus 3, I think I'm going to have to square that. X minus 1, I think I'm going to have to square that. Let's just go ahead and square each of these binomials. Now if you remember, the square of a binomial comes out to a trinomial where you have a 2ab in the middle. It's a perfect square trinomial. So we've talked about that. I'm just going to go ahead and crank this out. So x plus 3 quantity squared, that gives me x squared plus 6x plus 9. The x minus 1 quantity squared gives me a plus, here's my plus from there, x squared minus 2x plus 1. And on the right side, I've got x squared plus 8x plus 16. Again, using my knowledge of perfect square trinomials. Let's go ahead and combine like terms on this side so that I've got 2x squared, 6x minus 2x, that gives me a positive 4x, 9 plus 1, that gives me a plus 10. And on the other side, I still have this other trinomial, x squared plus 8x plus 16. Now to solve for x, I would prefer to have everything on one side and a 0 on the other side. Then we can use one of our techniques for solving quadratic equations. So I'm going to move everything on the right over to the left. You can do that by changing the sign, or you can simply use the properties of equality. Let me subtract x from both sides, for example. Squared, that is x squared. Let me also subtract this 8x from both sides in the appropriate place. I'll subtract the 16 from both sides in the appropriate place. And what I have left is 2x squared minus x squared is x squared. 4 minus 8 is negative 4, so I got a negative 4x. 10 minus 16 is negative 6, so minus 6 is equal to 0 on the other side. I've got a quadratic equation in standard form here. We have this equal to 0, so I can use one of our techniques. Can we factor it? I'm looking at the negative 6 to see if this factors, and it does not look to me that any of the factors of negative 6 also add to negative 4, so that doesn't quite work. Let's go ahead and proceed to using the quadratic formula. To use the quadratic formula, we simply state the solutions. And recall, the quadratic formula is x equals negative b plus or minus the root of b squared minus 4ac, and all of that is over 2a. And this is related to the standard form quadratic equation, so which looks like what we have above. Let me start to fill in the values. I'll change to my blue here. b is negative 4, so this is negative negative 4. You could right away just call that positive 4. I'm just labeling it in detail. Plus or minus the root of parentheses negative 4 quantity squared, that's my b squared, minus 4a, which is the number 1 in front of that x squared. c, there's my big long root symbol, and don't forget this bar. This stuff in the numerator goes over 2 times a. And then carefully continue from here. Let's see if I can continue it up here, which is just the math way of scribbling all over the chalkboard, right? Or the glass in this case. So what do I have here? 4 plus or minus root 16. I like to do the negative 4ab all AC, excuse me, all together. So negative 4 times 1 times negative 6 is positive 24. Okay, all over 2. And continue. This gives me 4 plus minus root 40 all over 2. The square root of 40 can be simplified. You can think of 40 as 4 times 10. The square root of 4 is 2, so this would leave me at 4 plus or minus 2 root 10 all over 2. Please review how to deal with these roots. I can divide both terms in the numerator by 2, and that would give me 2 plus or minus root 10. Okay. And from here, I've got two solutions. One of those solutions is 2 plus root 10. The other solution is 2 minus root 10. And I'm kind of curious what these are. I've got my calculator here, my handy-dandy calculator. Root 10 is about 3. It's a little over 3 because the square root of 9 is 3. So this is somewhere around 11, just a little bit over. But let's not estimate that much. Let's go ahead and use the fancy-dancy calculator. This gives me about, for the top one, 5.2 rounded to the 10th place. And on the bottom, I get about, let's see, 2 minus root 10, about negative 1.2. Negative 1.2. OK. So I've got two solutions for x, but I'm going to come back to my original triangle and see what makes sense and what may not make sense. So recall that every length has to be positive, right? If I look at the x plus 3 and I put in a 5.2 for x, that would be OK. And if I put in a negative 1.2 for x, that would still be OK. This would be a positive value. If I look at the next one, if I put in a 5.2 for x, that'll be OK. If I put in a negative 1.2, now I'm in trouble because I end up with a negative number. So what I'm going to say is that the negative 1.2 is extraneous for this problem. The only solution I have then is x equals 5.2. Again, we call that one extra, or the long way to say it is extraneous, which means it just doesn't apply to this particular problem. Mathematically correct, but not correct for this context. So let me go ahead and stick in the number 5.2, and what would that make the rest of this? Well, 5.2 plus 4 is 9.2. And so here's my longest side, 9.2. 5.2 plus 3 gives me an 8.2, so the bottom is 8.2. Units, I didn't give these units, so I'll just call it units generically. And then 5.2 minus 1, running out of space here, gives me a 4.2, and that's this length of the triangle. So here, I'll stick that on the inside. 8.2 here, 4.2 here, 9.2 here. And here's another fun application. Of course, these don't have to be binomials, and I think as you're seeing now, I could put a trinomial there, a quadrinomial here. I could put whatever nasty thing I want. And you can still use Pythagorean's theorem to at least relate these three quantities in whatever form they come in. So I hope this has been helpful. Stay tuned for more fun with Pythagorean theorem.